Okay, so we're going to talk about bivalves today. Yesterday, or last time, we talked about gastropods, snails, slugs, things like that. Today, we're going to talk about bivalves, which are the clams and the oysters, that type of thing. So remember that there is the lab is due today. We've had about 4 play posit assignments this week, I believe, and then the clam dissection lab that's due today. Make sure you get that done. It's with only 5 grades. If you don't do a lab, your grade's going to be very bad. So anyway, let's go ahead and get started. Okay, so before we get started, on the chat, please answer the following question. It shows up. Where do pearls come from? Go ahead and type that in on the chat. Okay, not bad. Clams, oysters. Yeah, it's mostly oysters around in the Gulf Coast and everything, but yeah, clams and oysters, bivalves. Basically what happens is they get some sand stuck in the shell, something uncomfortable, and to make it to where it doesn't irritate them, they surround it with shell material from the mantle and move it out, and you end up with pearls. And they can, some of them are very valuable, some of them aren't. I've seen people find them at the restaurants when they're eating oysters, and they're small and not worth very much. But then some of the others can be worth a lot. They actually culture pearls now, where they grow clams and actually put sand into them to make the pearl. I've even heard of them putting shaped objects in there, so you can have like a heart-shaped pearl and that kind of thing. Pretty interesting. Okay, so bivalves. The word bivalve means 2 valves, bi like in bicycle, or 2 shells. Val means strong, like valiant or valor. So bivalves are hinged. They have a hinged 2-valved shell, and examples are oysters, clams, mussels, and scallops. They have these really strong muscles right here, which you should have seen in the dissection, that can close the shell, and they're very strong. You're not going to be able to open a clam by hand. In fact, if you try to just pry one open, you'll probably break the shell. When you do the dissection, if you watch the video, these muscles had to be cut before you could open it, even when the clam was dead. And we'll watch a video of them preparing clams to eat here in a little bit, and you'll notice when they open the shell, they take a knife and they cut around the edge. And what they're doing are cutting these 2 muscles. Unlike the gastropods, there's no head, no radula. The radula is that scraping tongue. They don't have that. They're filter feeders. They have a sedentary lifestyle. They don't move very much, though they move more than you would probably think. I'm always amazed when I see clams moving, because you don't think of them moving, but they can. They move, some of them quite fast. And some of them, like scallops, can actually swim through the water. We'll see videos of that. They open and close their shells so fast that they squirt water out behind them, and it's a jet propulsion, and they can swim. Then you have things like oysters, which are firmly attached to a rock, so they don't have the ability to move once they attach. Some have a muscular foot for burrowing, like clams. Here's the muscular foot. And here's something that's pretty weird, because their gills are used for filter feeding. It's kind of like if you were using your lungs to eat. It doesn't work. But for bivalves, it does. Their gills they pump water over their gills to bathe them in fresh water to get oxygen out of the water, but they also trap food particles, plankton, bacteria, just little things floating in the water. The water enters and leaves through siphons. They have an in-current and an ex-current siphon. So water comes in, goes over the gills, and then goes back out. And if you notice in this picture, the anus dumps into the exhalant siphon. So while they're pumping water through their bodies, the waste gets just dumped into the water flowing out. You will need to know this in-current and ex-current siphon. This is a siphon on a giant clam. And speaking of giant clams, they're very large enough that you can sit in the shell. They can get like 3 or 4 feet across, maybe even bigger. And it's not like in the movies and the video games. They don't hang out waiting to trap something inside their shell. The shell can actually not close all the way. It closes a little bit, but not all the way. If you watch, see, that's as tight as they can close. And even if they did close on your foot or something, it would just be an accident. They're not doing it to try to trap you. Okay, so first polling question. Water passes through a bivalve from where to where? Only about 4 of you have answered. You've got 10 seconds left. Okay. So most of you got that, in current and ex current. Remember, X means away from. Okay. Some are the longest lived animals on the planet that we've found. This clam was collected in the Arctic, and unfortunately when they collected it, they killed it. They collected, a lot of the times when you're taking samples like this, you collect the animals, you kill them, put them in formaldehyde to keep them from rotting, and then you take them back to the lab and then you do your analysis. Well, when they analyzed this one, they found out it was between 405 and 410 years old. And that's the record for the longest lived animal that we found. That doesn't mean that other animals don't live longer. It's just the oldest one that we've been able to prove. If you think about it, it's kind of hard to find out how old an animal is. When I worked with sea turtles, people always asked me how long they lived, and we didn't really know because nobody had ever hatched a baby in captivity and watched it until it died of old age. They guess that they can live 100, maybe 150 years, probably not 405 to 410 years. That's really old. Of course, plants, trees specifically, can grow a lot older than that, but for animals, this is the record. Okay, these are called coquinas, and they're found on the Gulf Coast. They're about 1 inch long, and I want you to notice the shape, how this one's pointed and sharp. Well, when the waves wash them out of the sand, they can actually pull themselves back into the sand very quickly. They stick their muscular foot into the sand, spread it out to anchor it, and then pull themselves down. Let's see if this will work this time. Very quickly. Certain times of and larger clams do it too. This is a razor clam, probably about 6 to 10 inches long. And you see that foot's trying to get a purchase in the sand. It can't yet, but once it does, it can pull that whole shell right into the water, into the sand. You can see this is the in current and the X current siphon right there. It just pulls its whole body down into the sand, and it can go fairly deep into the sand. A lot of the ones that keep themselves really deep can't pull their whole body into their shell because they don't really need to, because they just pull themselves into the sand, the mud. This one is moving a lot, and the people are very entertained by it. It's called a quahog clam, pretty common in some places.
Ah, c'est salé ça. Tiens, là. That's it. Here it comes.
C'est fucking gross! Shake.
And even on a tablecloth. Well,
Oh, Seigneur.
Non, je veux pas y en donner. Je vais aller. Mais avec la caméra sur la table, peut-être. Hey, lâche mon wallet, là.
And here's what they can do in the sand. Again, you can see the siphons really well right here. This one's out of the water and it wants to get back into the water.
Look.
Cool. That was so cool.
Did you get that?
Yep.
Scallops can actually swim. Scallops have eyes where they can detect light and shadow at the very least. They just open and close their shell and it's water. This next one's a different species that swims even better, and there's lots of them.
Look at this. Look at this. Look at this. Oh my gosh. They're so funny.
That's bizarre.
They're so funny. They're so funny. They're so funny.
Okay, so this is a very odd clam called a gooey duck, and it's spelled geoduck. I don't know how they get gooey out of it, but that's how they pronounce it. And this is another one that buries itself deep in the sand. You can see the muscular foot is really, really long, and the shell is very small. It lives in the Pacific, and you make sashimi out of it. And sashimi is something they serve in the sushi bars.
I'm in. What is this thing hooked up to?
A water pump.
Where's the water pump?
It's out on the barge. We got hose that runs from the diesel pump clear into here.
Okay.
Then just dig around your feet and you go down.
And that's how hard the water's coming out. Not like that hard. So far, this is the job. I take this hose and I squirt it on my feet, liquefying the sand around me and slowly sink into the beach. All right, I'm sinking, but not fast enough.
And work down.
Uh-huh.
And then you'll fill a neck. Here, grab my hand, here.
Yeah.
And I'll show you. Go down.
Uh-huh.
And then you reach down. Feel the neck right there?
Is that
That's a
neck?
gooey duck neck,
Oh,
right? Right there. Feel it?
Oh yeah, I got it.
Okay, now get ready. I'll go down beside it, and then you'll pull it up when it loosens up. You'll feel it loosen up.
My first gooey duck.
And yours is bigger than mine.
Well,
Here at Puget Sound, there's over 109 million gooey ducks living under the sand. If left alone, they can live up to 146 years, making them one of the longest living animals in the world.
okay. Let's say I wanted to go eat one of these. Where would I go?
To Sins and Shelton.
Sins in Shelton. You mind if I take a couple with me?
No, go right ahead.
You mind if I say goodbye now?
You're not staying the whole tide?
No. I'm frozen. The tide's coming in, and you guys are crazy. No offense.
Hey, enjoy your dinner.
Yeah. Sorry about the shoe. Hey, is that a gooey duck in your pocket? Or are you just happy sashimi? Zen? You Zen?
Hi,
Hi, I'm Mike.
how are you?
I'm fine. I don't have names for these, but what do you think?
Oh my gosh,
Thank you.
this is nice gooey duck though.
These look good?
Yeah.
No, tell me,
beautiful.
wait a minute. How are we going to prepare it? It's sashimi, right?
Yeah, the top part of it, you're gonna have them sashimi. The bottom part, you either saute or you bread them and pan fry them.
Those are the two best ways to eat gooey duck?
Right.
Sashimi and saute.
Yeah.
You're just going to throw them in hot water?
6 seconds.
6 seconds. That's not a lot of time.
No. There you go.
1, 2, 3, 4, 5, 6.
And then you go along the other shelf. Watch this, okay? You have to go.
Yeah.
Well, this is how long when the neck stretched out. So down.
Magnum. Wow.
You take the gut right here, cut the gut off. And here, see? It's a beautiful piece of meat.
That's a beautiful piece of meat. Yes, it is. Against the laws of God and man. Oh, dear.
Cool. This one longer than the other.
Well, yeah. It's like that in nature. What do we do with the skins?
Pull it off. There you go.
What do we do with this?
We throw it out.
Seems like we should do something.
Yeah, let me go wash all this and then
Okay,
I'll
you
be
do that.
right back.
I'm just going to conduct a quick little experiment. Let's have a look here in the gooey gut, shall we? Something I never got to do in science class. See what these little fellas eat out there. But yeah, that's obviously the algae that they eat in there. It's got to be. What else would it be? Right? I told her not to leave me alone.
What you gonna do? Cook that up?
Well, yeah, I did a little something fancy with the stomach here. This is how new dishes are created.
Little garlic and butter and onion. That would be good. It would be good. It's eatable food.
So this is the stuff
That
we see in the sushi bars.
Yeah, yeah.
Uh-oh, too thin?
No, that's good. Then
Yeah?
better. Go ahead, do that. I'll
Okay.
find the wasipa.
She's leaving me alone again. Always dangerous.
See, you're gonna have to try it out, huh? To a lot of people, that's the best way. And crunchy. Good.
Oh, that's good. That is good.
We don't have to eat the gut today. So.
We don't have to eat the guts today. I mean, how bad could it be?
You're going to try? Told you you're crazy. Here.
Gooey duck. The other white meat.
Okay. So the next one is we're going to talk about our freshwater clams. These are freshwater clams that live in rivers and streams. And clams have a problem with living in fresh water because the water is flowing and baby clams are planktonic, which means they just drift through the water. So if you are if you're a clam and your babies all drift in the water and you're in a river, every successive year the babies are going to be further and further downstream until they're in the ocean, which is not where a freshwater clam wants to be. So they have to find some way to not only not go downstream, but to spread themselves to other areas. So they do this by attaching themselves to a fish. This is a baby clam, and it anchors itself onto the gills of a fish. And it actually drinks the blood of the fish while it's there. It looks like this. And then when it gets large enough, it lets go, falls into the water, falls down to the bottom, and grows up as a regular clam. And then when it has its babies, it releases them to the fish again. Now the problem is the clam can't squirt the babies very far, so the fish has to be basically touching the clam for the babies to get squirted into its mouth. And the way they do that is with lures. All of these are part of the clam, different clams. This one looks like a worm. This one, believe it or not, it looks kind of like it has legs, and when it wiggles, it looks almost exactly like a crawfish moving around. This fish right here is not a fish, it's part of the clam. These as well, this is imitating an insect larva. And again, this looks like a fish. This is what the gill filament looks like with the baby clams attached to it. So here's the crayfish lure. Watch this. Isn't that bizarre? And a lot of fish really like these crayfish. Look at this. It not only looks like a fish, it looks like a particular fish. Ones that are common, small fish that are common to the area that the bass really like to eat. And again, this one looks like the insect larvae. And this is the actual insect larva. This is the lure.
In the streams of Missouri lives the Lampsilus mussel, a simple animal with an extraordinary life cycle. To reach adulthood, its young must spend part of their lives inside a fish, the largemouth bass. To get there, the mussels must make physical contact, a difficult task, as mussels don't swim. But the bass has a weakness. It's a voracious predator of small fish, particularly darters. Even the slightest wriggle of a darter's tail will attract bass. Believe it or not, the fish on the mussel is an imitation, a perfect replica that will lure bass within striking range. The mussel can somehow sense approaching fish and wriggles its lure faster to entice them. If it gets the twitching just right, the remarkable likeness should do the rest. On impact, the mussel squirts its young into the bass's mouth. These snap shut on the gills, like spring-loaded traps. Here they stay, drawing blood from the fish, until several weeks later they drop off as tiny, fully formed mussels. Also a favorite prey of the bass are these striped shiners, and some mussels mimic them. Considering mussels are blind and have never seen a shiner, the likeness is incredible. The eyes, fins, and even the stripe look just right, yet the mussel knows nothing of its own appearance. These lures have evolved because bass more often attack mussels that look like fish, so fishy-looking mussels leave more descendants. After millions of years of blind evolution, this process of selection has turned mussel flesh into a lifelike lure. It takes a good imitation to fool a bass in clear water, and some of them are incredible. This darter mimic even has a mouth which gulps. This mussel is the same species, but its curious leopard print design may not find a taker, and its genes will go no further. This lure looks pretty good, but the bass is unconvinced and turns it down. Mussel lures are constantly improving, but fish are getting ever better at recognizing fakes. It's another arms race, and it's still creating diversity in the streams of Missouri to this day.
Isn't that amazing? That's just mind-boggling to me. Okay, so that was class bivalvia. Now we're going to talk about class Polyplacophora, just real quick. Remember, the gastropods had 40,000 species. Chitons only have 800. They're a pretty small group as far as mollusks go. And it's basically an armored slug. So it's got a body like a slug, but it has 8 overlapping plates on its back. They range in size from a couple of inches to very small. Like I said, the ones in my aquarium are about a half an inch. But they're interesting creatures, but that's all we're going to say about them. Okay, so next week we're going to start talking about cephalopods, which are one of my favorite groups in the animals. I have several favorite groups, but cephalopods are definitely one of them. So the octopus, the squid, and the cuttlefish. So let's see if those. Okay, so yeah, octopus, squid, and cuttlefish will be next week. Make sure you do the dissection lab and the videos. Like I said, I think there's 4 play posits from this week that you need to do. And definitely make sure you do the lab, because the labs are worth the most. Okay, that's all I have for today. Y'all have a good day and have a good weekend and stay safe. If you don't have any questions, you're free to go.